Hi everyone. So if you could please take your seats, we need to start the last session for today. Hi everyone, so we're going to kick off last session for this Smart Summit. So to kick it off, we have a sponsor president from KCI, Beth Ostrowski.
Hey everybody, I am Beth Ostrowski from KCI Technologies. I'm our regional practice leader in Nashville, Tennessee. We'll keep this short today, but we do have Jonathan Clayton here with me and Holly Painter as well. Hopefully you've had the opportunity between the three of us to speak to most of you. If we haven't had that opportunity yet, we're short on time now, so hopefully we can squeeze us in and we can say hi at the end. I am seeing some friends' faces I haven't chatted with yet, so there's a lot of us here, which is great. We just have a little video to tee up for you, and appreciate being here and glad to sponsor. Thank you.
Thank you, Ben.
Installs, integrates, inspects, maintains, and manages the infrastructure and systems critical to sustain our communication and transportation networks. We have planned and installed more than 18,000 miles of fiber optic cable and 4,000 small cell sites. As leaders in wireless and 5G, we are proud to create a more interconnected, livable world. Whatever your ITS or communication needs, we are driven to rise to the challenge.
All right, thank you, Ed. So I forgot to introduce myself. So my My name is Kamrul from Chattanooga in Georgia, and I'll be the moderator for this session. So we'll start off with presentation one for this last session. We'll start with Padgett. He has 18 years of experience with the Tennessee Department of Transportation, along with being a registered professional engineer in Tennessee. In 2005, he earned his Bachelor of Science in Civil Engineering and his Master of Science in 2006 from the University of Tennessee, Nashville. Mr. Padgett has worked for TDOT since September 2006, where he began his career in the Regional Traffic Office of TDOT for the first 7 years, and then served as Civil Engineering Manager in the Project Development Division, where he managed T3 and specialty projects such as resurfacing, bridge replacement, rockfall mitigation, alternative projects, SIA projects, and construction management. Mr. Padgett now acts as Regional Traffic Operations Manager for Region 1. All right, undergraduate.
All right, good morning. So this is day number 125 after Hurricane Helene hit East Tennessee. If you can queue up those slides for me, please. All right, so Hurricane Helene hit East Tennessee and Western North Carolina. Now, if you're from East Tennessee or Western North Carolina, raise your hand. All right, have you ever had a hurricane hit in East Tennessee or Western North Carolina? Right. Yeah, we had either, we have rain events, we have different storms, we have slow failures, we have hard winds, but never a combination of all three and across 6 different counties. So when that happened, it was kind of a rush. This is a big emergency. So TDOT took on Hurricane Helene and had partners across the state as well. But I want to show you a brief video just to summarize what happened when Hurricane Helene hit.
I've never seen nothing like this. Be honest with you, it's a mess.
There were over 1.2 million gallons per second of water coming over the Nottage Dam. The peak daily flow for Niagara Falls is right at 700,000 gallons per second. So we are almost double. Farther. What happened?
All right, so that just kind of gave you a brief overview of some of the tragedy that struck there. So when Hurricane Helene hit, we had about 49 different roadways that were completely closed. So that included about 14 bridges that were closed, and 5 of those were completely washed away. So along the corridor of the Nottage River, we had the river come up, and it actually hit some of the bridges that were about 60 feet above typical water source. You had 31 inches of rain that fell in western North Carolina, came through that Nottage River corridor, and actually took out some of those bridges. You can scan some of these QR codes. I don't know, they're pretty far away from where y'all are sitting, so they may not work. So basically, we have a detour plan that we put out there. We have a website dedicated to the Helene recovery efforts, and then we had just a disaster response map. So our aerial survey group, they went out and they actually mapped some of the corridors where we had the worst failures. And you can actually go through there with a slider tool, and I'll show some of that further in the presentation. You can see what was before and what happened like the day after the floods came through from the rain from Helene, and then kind of step through of what we've been able to do so far. So a little bit of what I'm going to talk about today is the regional response, how our region responded, and really statewide, how we responded, TDOT as a whole, to this. Then deploying technology. So we already had some things in place, but what did we do as far as deploying temporary stuff, and then the last thing I'm going to go over some things that we restored, and then just to save time, I'm just going to talk about the 2 interstate projects that we're working on. So overall, there were 6 main counties impacted in East Tennessee. You had Johnson, Unicoi, Carter, Greene, Washington, and Cobb County that were impacted the most by that. So we set the director's conference room. Typically, when something like this hits, if it's a slow failure, if it's something like that, our regional crews usually go out and take care of these things. Well, he's on the phone with the other 3 regions as well, their directors. And the first question they ask us is, what can we do to help? So they send crews as well. So we have over 400 employees working on this within 2 days. We have over 20,000 hours of work that is going on. These guys came out and they helped us tremendously. So looking at that, so we had all 4 regions. They all came to Region 1 to help. And they didn't just send 1 crew, they sent a whole lot of crews. So we have a group in our maintenance division, our floating maintenance crews. So that's like the heavy construction folks. They do a lot of grading, they do a lot of paving. So they send all of their crews out. We have a strike force team that goes into other states and helps them during disasters. So we've been down to Florida, we've gone into Louisiana just to help them with debris cleanup and different things. So that was the crews that came to us to assist. So all these guys were deployed into those 6 counties in East Tennessee. And then we also had Florida DOT come up to help us assess some of the damage that was done by the hurricane. And these are guys that have worked on hurricanes in Florida, so 20, 30 years worth of experience, and they came to our director and said, we've never seen something this bad. So that tells you how big of a catastrophe it was for Tennessee, for East Tennessee, and then just think about on the North Carolina side, it was even worse. So I was listening to a news conference a couple of days ago, and they still have 180 roads that are closed. So we had 49 to begin with. They have 180 roads that are still closed. So as part of the deployment, our other region folks, they actually sent help trucks to help monitor 81. Because of the hurricane, we had Interstate 40 and Interstate 26 closed. They were completely closed. There was a bridge on I-26, and we had portions of the eastbound lanes of I-40 that were completely washed away by the flooding of the river. So all of that traffic, they were going up 81 over to 77 to get back down to North Carolina. So we had additional help there with our help units. So looking at this map, and I know it's really, really small, but day 1, all of these things were red. So red means really bad, green means really good. So this is an updated map. We've been able to open up 42 of those 49 routes to 7 that are still remaining that are under contract being worked on right now by contractors. There's 1 that still needs to be let, and it's an alternative delivery project that will go up here. I believe it's tomorrow, the bid letting will open. So after that, we'll have everything under contract. So this is just a list of the road closures that are still out there, and I know it's really, really small. The good thing is it's getting smaller. And that was the key thing that we wanted to show to our commissioner, to the governor, is that as we're doing these things, we're not just sitting by letting them just saying we're going after them and actively looking at. Again, bridges, and 5 of those bridges were completely washed away. We started with progressive design build, so that was some of the first progressive design build contracts in the state that we've done. Hewitt has those, so they've come in with the design team and they're completely rebuilding those bridges. So one of the things that folks kept calling us about was what's the alternate route? What's the detour? Well, when you have multiple bridges that are closed, not just state routes but county roads, there's really no detour. The safest thing for folks is just not to travel. And I understand that's not the thing they want to hear when a loved one is on the other side of that bridge and they don't know if their house exists anymore. But that was the biggest thing. We had really no alternates on state routes. We had alternates on the interstates that folks were able to travel over, 81 to 77, that was a 6.5 hour detour. So folks were trying to get through all these other roads, and our message, anybody from Tennessee trying to get to North Carolina, was all the roads in North Carolina are closed. So even if they tried to get there, our statement officially was, you can't get there right now, using those state routes or even local roads. So this was really the only map. This is updated now because we have I-26 open. But this was really the only map we put out there officially and say, here's our detour. So deploying some of those ITS devices, the key thing that we wanted to make sure we do is have something that we could get into quickly and make sure that we could get different messages as folks are traveling through there. So we use these portable message boards that, we could, if we had cell coverage, we could remote into and exchange messages, but a lot of times we did not even have cell coverage there from the start. Cell towers were down, and we just had to have our maintenance guys run out there and do that. And of course, they love to do that because they're trying to grade and get stuff off the roadways as well. So you had to take a team, send them somewhere, couldn't communicate with them except maybe by text or messaging, and they would have to go in and change message boards. Another thing we learned when we were deploying these things, how many people know what a CME is? Just a couple. It's a commercial motor vehicle. Wouldn't it be a good thing if the commercial motor vehicle drivers knew what a CME was? So that was another thing. We had to start putting up pictures of a truck with a red X over it, like you can't go through. They would read the message boards and say, oh, that's not me. And they would keep going, get to the end, and guess what? It was a hard time getting turned around. So we learned a lot about using symbology and making sure that folks understood the way that they could go and the way they couldn't go. So we would have red X's over the trucks and then a green arrow if they could get off the exit and turn around. So that was a big thing. The other thing we deployed, we worked with the first time at ATCMTD. This was the day of the rain event. And we said, we know we're going to need a CRD, so a compact, rapid, deployable. That would help give us at least a 2-mile radius of cell coverage and potentially have Wi-Fi for our guys. They could take it, they could put it behind their truck and take it with them wherever they were so they could at least communicate. So the big thing about these two things, the CRD, it has a generator with it. You just have to make sure you have gas, keep filling it up. With your message board, yes, it works off the battery, but guess what else you have to have? For solar panel, sun. No sun means it drains it and it goes out. So we constantly kept getting phone calls from our highway patrol folks saying, hey, you got a message board out here that's not working. Battery's dead. So we had to constantly work with those different things. So even though we had stuff that we could deploy out, we were constantly having to go back and maintain those as well. So another feature that we looked at were our mapping partners. So we already had some experience with Google and Waze, and our folks from our headquarters office, they've helped tremendously with our region in particular. Back in January of 24, we had a small snow event, we call it Snowmageddon. We had 10 inches of snow with 2 inches of ice on top of that. And even though the roads were clear in a lot of places because nobody was traveling on, Google kept saying, roads closed, roads closed, roads closed. So we were getting in there, talking to Google, saying, hey, you got to get this back open. They're not closed. Our guys are plowing as fast as they can. All of this is going on. So we already had a relationship built there. Then fast forward to the end of September, and we have this thing. So nothing that happens just for whatever reason. There's always a plan in place. So our plan here was we had the connections made, and we were able to talk to Google and Waze and tell them, hey, we have 49 roads closed, here's where they're at, here's where we need to make sure we have closures in place. As we started opening them back up, when we knew that vehicles should not be on there, even though they were open, we would talk to Google and Waze and say, hey, we know your analytics are going to show this thing's open, but we need to change our algorithms just a little bit to keep them closed. And they worked with us tremendously. DriveWise, a lot of roads on here as well, so TDOT now has a contract with DriveWise, and I think this is going to actually help speed that up a little bit. But we were working with North Carolina DOT, which had a contract with DriveWise. They were putting in messages for us for the trucks. I wish all trucks had DriveWise or something like that because they constantly use Google and Waze just like a passenger vehicle does. So they were being directed through just like a passenger vehicle would be, and then they're going to get stuck as well. So we can do so much with driver lights. Again, it's limited because only about 30% of truck drivers use that tool. So even though we work with them, it's only getting to that chosen few. Then it's never that person that can't make it through there, right? He's a professional driver. He's a CMV driver. At least they know what CMV is, but I'm going to go through there. So working with all of those folks on the technology side, then we work with our Smart Way folks and our IT guys to put special layers on Smart Way. If you pull up Smart Way before the event, all you would see was maybe the cameras and the message boards. So as we deployed our messaging, we started in about Middle Tennessee, right there on the Kamrul County, started messaging, and then we gave messages of I-4 is closed, use 8126, or I-4 is closed, use 8177. And in most cases, for those wide loads that are over 10 feet, they had to use 8177. I was able to go up to DC, and you know, it's about 100 miles once you get into Virginia to get up to 77. So those truck drivers, they were having to really haul, going up 81 to 77 to get back into North Carolina. So just having an existing infrastructure there helps. And I know Andy presented earlier on the deployment plan. We would love to have that deployment plan already in place in Cobb County to help us get through there. But in this case, we used what we had to get those. So again, I was talking about how our IT folks helped us out, get this layer on here, so major impacts. Not only was Google showing those major impacts to closures, we also have the dots and icons on there. So if somebody came to the Smart Way map, they were able to see where all those major closures were as well. You can click on those closures, and again, I know it's really small, but you can get on the Smart Way app as well and see those different things. So this is just telling you I-40 is open up to exit 451, and you can get to that point, and local traffic only, no CMVs, and I believe we even said tractor trailers over a certain width. Then on I-26, that is open now, one lane in each direction once you get to mile marker 39, and then we let them know that as well, and again restricted to those wide loads. So because of the increase in traffic, on I-26 right now, or typically, on a typical day, you have about 18,000 vehicles a day. With all the closures and everything, it jumped up to 24,000 vehicles a day. That's the only interstate connection that's open between Tennessee and North Carolina right now. So even though it's one lane for that about a mile and a half section, that's where a lot of folks are going to that aren't over that 10 feet. So what we wanted to do as well, we wanted to make sure that we could have eyes on those sections. Again, we're limited by cell coverage, we're limited by sunlight in some cases. So we worked with Gresham Smith and Whitney, and then Carolina traffic devices to get some cameras up there. So the easiest thing would be you throw a camera up there, you get it on there, it pops up on a Smart Way. That's the easy part, just say it. So you have to make sure you have this in part, you have to make sure you have a router that talks back to the TNC that is able to be put onto the network, and then have the device show up on the network, or put up to hold it on there. Anyway, we got 5 cameras set up for all these corridors, and they worked for a while. And then we started having the same issue as we message boards. Cell coverage went down, battery went down, your solar panels weren't working right. All those different things to say, it worked for a while, we were able to get it fixed a little bit more, and now we have our own devices back out there, they're sending some video feeds back. The nice thing about some of this I-40 is so closed right now. Unfortunately, North Carolina had additional slides, so they lost even more of the lanes, so they pushed off the opening of I-40 to about March now. It wasn't going to be January, because of that additional slide, they pushed it off. So with that, they're going to have some different coverage through there with the towing company, just to help get stuff cleared once we open back up to one lane in each direction across through there. So closing this last little section, I'm going to talk about restoring connections. So again, we started out with 49 different closures along routes, We've been able to open up 42 of those. This is a list of the last 11, which is a combination of different ones that we recommend as well. So the nice thing is we're turning a lot of those red. So I know it's hard to read, but anywhere between May of this year and October of this year, we should have all these open. So that's the good news on these projects. So I'll go quickly on some updates for I-40. So that was an emergency contract that we met. That was a joint effort between Jones Brothers and Whatnot. And basically what we told them, you need to secure lanes. Use soul mailing, use different methods, means and methods to get those lanes to stop and slide. And they were able to do that. So now they've got a second contract that it's going to start restoring those lanes in the eastbound direction. Westbound is good. We have a 9-inch curve that separates one lane traffic in each direction, making those consistent. North Carolina is going to mimic that and continue that on as they work on their eastbound lane, which is split out. So basically, this is the slider tool. If you didn't get that QR code early, you can come see me after, and I can show you that. But basically, here's the curve of one of the curves on I-40 at mile number 450. And you can see here where this is pre-storm and here's post-storm. So the river kind of moved toward the lanes. And you can see it continue to fail over the next few days. And here you can kind of see where those hollows have been placed in there, and they've started recovering up the stairs. Then on I-26, we're forcing out there as well, and partnered with Summit Taylor. And right now, they've actually poured the eastbound bridge deck, so that bridge is completed. The good, nothing is good about this one, but the good thing about bridge failed is it was not over the river. So we were able to, and I'll show you this. Okay. So on the westbound side, we're actually filling the rock, pave over the top, and then it looks like this. So again, another view. So since it wasn't over the river, we were going to fill in, pave over, and then put that curve in place. So we can have one lane of traffic in each direction there. And this is what it looks like today. So we have traffic on the main. So this, again, is the only connection on the interstate that we have between Tennessee and North Carolina. So again, slider tool, so you'll see kind of in the middle of the screen where that bridge failed. And then here's our guys going to work. This is about 2 weeks after the event. They're already starting to fill it in. You can see they're bringing it up. They've got it paved. And then here's about 3 weeks ago, we had the bridge being set. About 2 weeks ago, we had all the everything put in place. And then we put all of the different traffic guys were getting ready, and then it started raining in or snowing. So we had to hold off on repouring that concrete. And this was actually on Tuesday, we're out there. Somehow we got 50 degrees and ready to pour concrete over a week. So this was there right now, they're waiting on it to cure. Once it cures, and we were able to get everything striped, switch traffic from the westbound side to the eastbound side. And again, have that one lane each direction to the westbound lanes. So for that,
thank you, Jenny. Presentation was great. All right, moving on to our next presenter of the day, Justin Hash. So, Justin is a graduate from Georgia Institute of Technology and has worked for the Georgia Power Transmission for 12 years. He has served in traffic operations projects in Cisco and Shanley as well as the State Traffic Operations Office. In his current role, he serves as an assistant state traffic engineer, leading the state's traffic signal maintenance and operations program and advancing state's connected vehicle goals. All right, welcome to us.
Thanks for the opportunity to be here. I have gotten the opportunity to speak a few times on GDOT's SpeedX program. We're starting to refer to VDEX, vehicle to everything, as opposed to connected vehicle, but the same thing we've been working on since 2017. And multiple folks have been presenting on. So we are trying to shift some of this towards where GDOT's heading. So that's where we're going to get to at the end of the presentation, is what our roadmap is for the future, and a couple specific applications we're really focusing on now that will help keep us effective as we continue to grow. But first, I do want to touch on a couple applications, reorder these slides a little bit from usual, and hopefully speak to what we're heading towards before we get into those technical bits. Sorry, I'm just trying to get my minutes over really quick. No, right here. All right. So where GDOT stands today for our VDEX program, we've got about 2,000 RSUs deployed statewide. We did deploy, I was thinking someone just a moment ago, a lot of ESRC towards the beginning. Thanks to the second rule of order, we will have to we will have to be, moving over to VDEX or CVDEX deployment. We have been deploying dual mode radios for quite a while now in anticipation of that potential move. So we are ready to do that. Like I said, 2,000 RSUs currently deployed statewide. We have programmatic funding, which is really valuable to our program, to be able to deploy a set number of devices per year. We've got dedicated funding for 390, and then with the other projects we're working on, we're going to do well over 400 a year, we feel, moving into the future. So some of that will be replacing some DSRC, and we should see these numbers continuing to grow across the state. One of the projects I'd really like to speak to is an ATCMTD grant, actually two, the department one, speaking a lot towards how we got to where that map you last saw. But when we first got past 2017, the dispatch challenge and all that, we decided it would be best to approach VDEX through a regional deployment, but you're not going to see the true benefits of connected vehicles without regional deployment, just single corridors and vehicles not being able to be on multiple corridors and experience benefits. It's just not going to translate to the traveling public or to even local agency staff and local agency vehicles. And so we really had this vision to pursue was our RTOP program at the time, our SIGOPS program, in deploying to 1,600 signals statewide or across the metro Atlanta area. We did that primarily for our first ATCMTD grant, which was almost entirely focused on deployment, a little bit on tracking to make sure we had these devices functioning properly. And really, enable seamless use of this technology throughout the metro Atlanta region. Any partner can come in and enable various applications that we need to. And then hopefully from there move on beyond just pilots, which we've talked about a lot over the years, to regional deployment. A second ATCMTD grant we won was much more focused on utilizing that deployed technology in a specific area. So if you're not extremely familiar with the Atlanta region, this is you can see our perimeter around the outside of this picture. And then, we refer to it as the connector, 75, 85 in Midtown Atlanta. Is where we have quite a lot of congestion throughout the city, and in this particular area, multiple emergency vehicles who have some tasks that are very much impacted by traffic in that region. So in particular, this grant is focused on wanting to assist our hero vehicles, which are our highway response teams, as well as private ambulance service or metro ambulance. Who's trying to get to the Midtown Hospital. And with that, we've got a lot of partners on this project. I think it speaks to interoperability and the fact that we want to be able to work with the private sector to deploy these applications. We want to enable benefits to the city of Atlanta and work with them, their traffic signals seamlessly. We want to work with private ambulance servicers. We want to work with our own hero staff. Not simply make this a traffic ops focused initiative, but really across GDOT. You can see some of our staff, our consultant staff who assist us along the way there too. And so here you can see a blown up map of that region we were showing earlier. Coming south on the connector there, there's quite a backup from the North Avenue exit. You're probably familiar with it if you drive there. That's right there at Georgia Tech. So for both the Hero Service Patrol as well as the Metro Lane ambulance, they get caught in that queue for various reasons. For Heroes, it's a pretty common need for them to potentially get from one side of the interstate to the other quickly in order to respond to an incident. This location in particular is not a simple U-turn, but they're going through 3 traffic signals to be able to make that U-turn back onto the interstate. And so being able to get a message from a Hero unit on the interstate and start moving traffic downstream for them so that they can make that full maneuver in orange that hopefully you can make out there is very critical to them. And quickly after we brought this idea to them, they're pointing out various interchanges across Metro Lane where they have the same issue, and so we really feel we're breaking through on a useful application here. Additional Metro Lane ambulance is trying to get to Town Hospital down there, and basically almost the exact same maneuver, just a couple other signals to get them a little further over. Additionally, Georgia Tech was listed on that partners page. They are helping us research this project. They're also, in a way, a stakeholder customer in this project. So they have a pedestrian hybrid beacon near the corridor, and so we can communicate, or we're deploying cameras that will help detect pedestrians there, and then generate personal safety messages to vehicles to notify them of the presence of a pedestrian or crosswalk, as well as enable coordination such that if we know we have an emergency vehicle trying to get through that corridor quickly, we can ideally hold that pedestrian crosswalk. And again, I spoke a lot about the vehicles, but we deployed 116 vehicles. A lot of success for GDOT's program has been statewide contracts that enable us to bring a lot of services that enable these applications. And so Gwinnett County is, I know here has benefited from that same contract for their fire engines, but we deployed both our Hero units and ambulances. Things you run into here are providing installation guides to retrofit vehicles where these are not in the factory installed yet. And then, yes, configuring those to request for entry at the right time. So, you have to work through with each stakeholder we have to make sure that you understand their procedures for when they're trying to go through an intersection with emergency priority, but also when maybe they might park near an intersection. So various things like relaying if lights are on, sirens are on, to their onboard unit, and then getting back to the traffic signal to make using that information to decide whether request priority from the traffic signal is critical. And something like parking brake being on implies, well, they might still have the lights on, but they're at the intersection. So we go through all that. Some other projects we worked on that I can speak towards this not just being single solutions. Was a freight system priority project we did down in Savannah. So if you're not familiar, that's a very, very busy port nationally, and especially on the East Coast. So it's quite critical to the department to be able to serve them as a customer of sorts, as well as just work with them to make transportation more effective. So we looked at these corridors as primary ones that were pushing traffic to multiple port entrances. There are a couple of applications we had in mind, possibly relaying upstream to a truck that there is a blocked road crossing downstream, especially in some of these port areas. You can get trains, loading and unloading, and possibly having a delayed closure trucks with one vehicle. You really cannot just make a U-turn and go around some situation like that. So upstream notification that is critical. More specifically on this, we really focused on was getting OBUs and private vehicles, providing them priority with signal timing, so getting 5 to 10 seconds of extra green time. We weren't necessarily looking to improve operations as much as show that we can build that partnership with private vehicles, let them know we have the capability of, so that hopefully those partners are approaching us when they have a very specific problem. But we did do a quick before and after study. It did show mixed results with some increased delays in the PM, but we did also see noted success in the AM peaks getting into those ports. And so I think it shows the application can work and we have found multiple partners, private sector partners with other car manufacturer elements nearby. Transit signal priority, I usually lead off this one, so I put it at the back so I won't get the question I got last time. But this has been probably our primary focus, or just our most deployed application so far. So these are 2 ones that are currently being worked on. One's in Savannah again, Chattanooga Transit was the first one to reach out on the partner on that. We're very excited about this one because it's truly just them asking us, you know, hey, we've heard about this, what can we do? And so we're ready to go with the deploy devices today. We'll talk more about how the program is built to achieve that, but you can go to Savannah now and you should start experiencing, if you wanted to ride with us, a quicker trip on these 2 routes, Water and Acropolis, I believe. And additionally, MARTA may or may not have seen any headlines about them pursuing a robust BRT program. That's very much their program, but we were excited when they came to GDOT and said, hey, you make this V2X solution easier for us, and we were ready to jump to it and help. And so this is, for Atlanta, this is some of the BRT on your right. And then they've got, several projects coming through the pipeline that will be able to mitigate some of that funding question. All right, looking to the future, we have a V2X roadmap, which I've embarrassingly put up for like a year now on these screens talking about it's coming, but we do believe it will be published. We thought this January, this month when we first wrote these slides, but I'm reasonably confident it will be published online for shared to all of y'all in February. And so if you've heard a random project or an interest or acronym, you just want to read more, it's all there. If you're interested in partnering with GDOT, we try and list in here how we can better do that. I'll briefly mention we had a vehicle everything program manager now in the department, and this is kind of was a big move for us. We joked constantly that the job management this program was not just a full-time job, but multiple people's full-time job, and we were managing it through our typical traffic operations, our arterial operations programs. So that's Victoria Coulter. She's very sorry she couldn't be here. She wanted to present today, but excited to work with anyone who wants to talk about this. So some stuff from that roadmap document. First, we really focus on this foundational investment piece, and so recognizing there's a certain part of the infrastructure that we can control, and to really make sure we're doing that to deployment of RSUs, but also working with infrastructure owner operators and public agencies on their applications where we can hopefully get OEUs and get priority service. But we do also want to target strategic expansion, and so where we see those private sector partnerships or where we see connected vehicle applications being more beneficial for a specific region, make sure that's where we're deploying first ahead of privately owned vehicles, hopefully wanting to leverage those applications. You can see some of our focus areas. I'm pretty happy that I think we hit most of the buzzword, the single words that where ITS is heading. Not security, but I'll get there. Safety, operations, and mobility are all here described in depth in that document. So moving forward, again, want to focus on those public sector fleets, but additionally, we're expecting OEMs to be putting these devices in vehicles, or hoping they'll be investing in putting these devices in vehicles soon. And they're not going to want to make that investment if this infrastructure is not out there. So that's why we're investing so much in pushing this out. And we want to ensure the infrastructure is ready prior to that need. The question that starts to bring up is, there's going to be a lot of assets that we have to manage. We have to stay ahead of that. It's more assets that none of our signal techs or other crews are familiar with. We have to train them up and give them tools to manage those systems effectively. There's going to be a lot of data. I think I would almost be redundant from everything we've heard today to go too far into that, but there's certainly data coming out of these vehicles that we need to get to multiple partners. and make sure it's managed appropriately. And then cybersecurity is of particular interest to connected vehicles, and we'll touch on that briefly. I got these out of order, I apologize. And so one of the ways we want to do all that, again, is thinking of this not as individual pilots or individual projects, but as a program. And so we've talked about most of this already up here, but additionally, thinking of this program as being able to share various data pieces that we can collect from vehicles out on the roadside, and then making sure that data is available. These are some applications we have listed in the roadmap to kind of show what we believe are going to be the most beneficial to the traveling public. Most of these are safety-based. I think almost all of these are safety-based applications. A couple of these SPAT information, red light violation warning, we have proven out. Others will require the private sector to develop someone to develop an application. We won't necessarily be ahead of all of those, but this is what we want to enable. And so our 5-year outlook is to continue building out infrastructure, equip state and local fleets, and establish those applications. Long term, we need to look at expansion of sharing data, as well as partnerships with OEMs. And so we're in those conversations constantly. Those are kind of a longer roadmap. Specifically, how we're going to get there in the near future. A few different things. One, you almost can't not mention our broadband program when talking about connectivity right now. We do have a need, if you saw the map, to expand all the way out to rural Georgia along our interstates actively, as well as have communications back to all those locations. And so this broadband program that our ITS group is leading up will be able to help us do that, but almost have to mention it. This idea for Georgia was really first envisioned from a hurricane that came through our Midway several years ago. We saw these same problems again, the vehicles leaving Florida, getting stuck on interstates like 95, trying to get through the state to where they're going. They get stuck in congestion. Nowadays you've got 4 people in a vehicle, and each kid's got their own tablet watching Netflix and Disney Plus and all that. That's loaded down the cell network, and when that happened, really got trained on this last week when we were working through it. Some other stuff. What I really want to show here is just that one, this is a partnership with Hasan through the Ray, which is down there near the Kia plant in West Georgia, and it's just been a very great partnership for us and enabled us to try out some things. Hasan has brought us this platform, which allows us to manage. Helps us to manage data coming from our RSUs, and we really turned it on just a few weeks ago for several locations. And so what you're seeing here is we just turned these on at Savannah and by the Ray to see, and we just had more data than we were expecting to get. So you can see the site generations by message type there. As it goes on, it gets cooler. You can just see the first week we turned it on. And I think, after the first day and more the second day, you just see those millions of SPAT map messages just from, I think it's only 30 or 40 intersections we're generating. And, again, security, there's not first identifiable information here, so none of this, can't actually tell you this isn't just a few buses that we had no view on, because we don't know yet, but and you can't tell which vehicle it is, but for us, this shows almost certainly that there's vehicles driving around out there spitting out information we can capture today. And yeah, like Victoria and I looked into this data and we started seeing things I'm not even sure what Great Goose status is, to be honest, but we've got that data, and we really want to make sure we're sharing these to enable applications. And a teaser. Day 1 deployment district, or ITS will be in Atlanta this fall, if you're not aware, and something we've been working through as an idea to show off what VDX is in Georgia and elsewhere. We're calling Day 1 deployment district, or DOD, throughout Georgia Tech. And so the idea of this is to create a deployment zone to demonstrate mature VDX capabilities. In fact, these devices are out there today. That if we deploy equipment today, applications are ready to go. This is not something that needs to be tested and proven, but rather something that's built out. So if you do want to partner with that, or if you're a local agency, just wants to be able to see that, come out and do, but if you want to partner with us, we will be getting information out quickly to hopefully explain what the requirements are going to be. Primarily, we're looking at things like on-the-air certifications. But if you want to talk more about that, look out for on-the-air Plug Fest, where we're thinking about getting some information out. And we'd love to partner with you and hopefully show that the attendees of ITS World Congress that this is here today. It's not the future. It's ready. Thank you.
Thank you, Justin. All right, moving on to the next presentation. We have three speakers presenting on Alzheimer's ITS sensing with LIDAR. Will Barbour from Vanderbilt University, Austin Harris from University of Tennessee, Chattanooga, Kamrul Hasan from Tennessee State University. Dr. William Barbour is a senior research scientist at the Institute for Software Integrated Systems and adjunct professor at Vanderbilt University. Dr. Barbour serves as the engineering and technology lead for the Tennessee Department of Transportation, I-24 Motion Testbed, and Nashville Department of Transportation's LIDAR project. His professional mission is to use intelligent transportation systems, solutions, data, and artificial intelligence to improve safety and mobility. Austin Harris is the Deputy Director and Chief Technology Officer at the Center for Urban Informatics and Products, part of the University of Tennessee at Chattanooga Research Institute. He leads cutting-edge applied research at the intersection of AI, big data, and intelligent transportation systems, fostering innovation in urban safety and efficiency through collaboration with academia, industry, and government. Dr. Kamrul Hasan is an assistant professor of electrical and computer engineering department. His research interests include cyber physical systems, computer networks and security, software-enabled network security, machine learning, and artificial intelligence empowered automation in cybersecurity. So please welcome.
We are actually presenting the first phase of our project. Can you hear now? Yes. Okay. So the first phase of under the Smart grant. This is our team. Actually, this team actually included leading by Nashville Department of Transportation, along with three universities, Tennessee State University, Vanderbilt University of Tennessee in Chattanooga, and also other partners on consultants and Tennessee Department of Transportation. So, throughout the outline, so we are actually trying to organize this presentation like introduction, or ITS side, data derivation. And then there are two use cases we actually described today. One is Nashville mobility case study, and another is mobility case study. First thing we have to do our summary of this project. Actually, the objectives, what are the objectives of the project? The primary aim is to support the Nashville Department of Transportation. Vision 0 Actually, Vision 0 here means we actually eliminate all traffic fatalities and accidents, injuries, while we are actually managing the injuries, safe road, at the same time we are actually ensuring equitable mobility. especially for vulnerable zones like pedestrians and cyclists. So why do we need this project? So if you look into that, traditional method of reporting, crash reporting, often fail to provide comprehensive insights. There are gaps in understanding the relationship between pedestrian safety concern and the ability of actionable data. This project actually addresses those challenges and shortcomings by introducing new ways to bridge this gap and improve safety outcomes. Normally, why we actually use the pilot for this project phase 1. This project actually is focused on a section of indoors areas high injury network. This high injury network refers to areas which is high concentration of severe crashes. Especially this project targets a historically underserved community of North Nashville. And this pilot project is actually part of 200 miles high injury network identified for interventions. So actually the long-term goal is ultimately in the phase 2, the ultimate mission is to extend this approach across the entire high injury network and potentially even eat. Okay. Now actually we have to talk about a little bit the technology actually we use LIDAR. Why actually we choose LIDAR? So everybody knows that LIDAR is a light detection and sensing, using scanning lasers to measure distances and detect the optical properties of objects in an environment. This is important. Optical properties actually measures. And by emitting lasers beam, analyzing their reflection, LIDAR gives a highly detailed three-dimensional representation of the surface. And second thing is, in addition to that, the LIDAR can able to precisely measure the distance of the objects, which actually usefully identify pedestrians, vehicles, and other objects in complex urban environment. All together actually gives a 3D spatial data improves and data which actually improves the situation around the safety analysis. At the same time, many of you have the question that LIDAR is costly, but nowadays LIDAR is the price of the LIDAR is comparable to other systems. Due to that and its benefits, LIDAR nowadays is actually widely used in all applications such as automated vehicles, remote sensing, and aerial service. Its reliability and precision in these industries demonstrate its potential for improving pedestrian and traffic safety. Now onward, actually the case studies and other AI and machine learning related things will be demonstrated by my teammates. Thank you.
All right, thanks, Kamrul. So I'm going to go through a little bit of LIDAR and ITS context. So if you all haven't seen what LIDAR installation looks like at an intersection or at another location on the roadway, we typically use up to 2 sensors at a single intersection for to cover blind spots created by the sensors and by pollution from other vehicles. And ultimately, what is generated here is the exact location of every object within the scene that the sensors can detect. And by generating these locations of all road users within the scene, we can build up the trajectories of how those objects move and ultimately understand interactions between those individual locations can be boiled down to zone detection, which is commonly used for intersection actuation. So the LIDAR here in this context can actuate intersection like your other ITS sensing technologies. Early on in the project, again, Kamrul mentioned the Vision Zero and pedestrian safety limitations of the technology and what we were trying to do with this project. This was a near-miss event that was captured, I believe, 24 hours after the first installation for the project. You see in this scene, which is kind of being rotated live here, this pedestrian in yellow crossing the intersection at a mid-block location, and then shortly after they cross through the roadway and onto the sidewalk, the vehicle passes behind them. So this might not look exactly like a super close call, but in actuality, it was pitch black dark outside, and this happened around, I believe, 10 or 11 p.m. So this, we're not sure whether or not the driver actually ever saw this pedestrian, but this kind of thing indicates the types of close calls that we're experiencing in this intersection. This one in particular actually was part of our validation of the technology. So we ended up writing over a 100-page validation report across the team as part of our Stage 1 grant, and that validation report included a lot of manual data validation as well as looking at using the technology to prove out interventions that we applied to the roadway. So in this case, we're looking at pedestrian behavior and our ability to detect whether or not we can change pedestrian behavior by deploying a targeted intervention in this particular area. So I won't go into exactly the intervention case study because we want to move on to some of our mobile applications. But we also did this in vehicle context and looked at vehicle speed and our ability to sense and intervene on speed of vehicles. We also looked at these near-miss events, and in addition to the automatic detection by the LIDAR processing, we manually validate each and every one of those events to make sure that we are getting accurate capture and classification of these near-miss events. So it's kind of small here, but there's a diagram showing lots of different modalities for these near-miss events, including turning vehicles, maybe not seeing pedestrians that are outside of the crosswalk, pedestrians trying to cross this 4-lane road. But by building up this library of these near-miss events, we can start to look at the highest frequency of particular types of events and try to intervene on those pedestrians' behalf of this particular location. The focus of today's presentation really wanted to make on some of the mobile applications. So these were LIDAR installations that I just went through at fixed locations on INDOT's high injury network, but we've also started deploying mobile versions of LIDAR. What that looks like is basically taking the same sensor that we have at the intersection, putting it on a telescopic mast from a trailer that provides power to that sensor as well as the computing and communication needs to get that data back all to the database. So this is a photo of our trailer in Nashville. So this trailer, we sort of aim for really long deployment times. And so with no intervention from any DOT staff, this trailer will run for a month or more with no touching. It's got a diesel generator and solar panels, and on a nice sunny summer day, we'll actually generate more electricity than it needs. So this is really targeted at longer deployments, and our first deployment that we used for this trailer was on Moser Street. So if anybody has driven this section of the National Roadway Network, you might know that this traffic circle often experiences a little bit of congestion caused by the interstate on-ramp, and in order to alleviate some of that congestion, this was a study about the signal timings and whether or not we needed to adjust split times and give more green time to traffic trying to access this traffic circle. What you see here from the plot is actually a time-space diagram of vehicles arriving at this section of Moser Street. This is really important because if you look at developing signal timing plans, you might have used one of these time-space diagrams, particularly in progression of a corridor. They're extremely helpful in seeing vehicle arrivals and departures from intersections. So this gives really high resolution data that we can use to look at vehicle waiting time, queuing frequency, and do that upstream of the intersection in addition to the intersection itself. So this deployment was, I believe, really successful. I won't speak on INDOT's behalf. You can ask them later whether or not they thought it was successful too. data and making changes to the roadway network as we speak. Looking forward to Nashville, we're moving on to stage 2 of this project and deploying this technology more widely across Nashville. Our next deployment location is going to be Nolensville Pike, which if you've driven that section of roadway can be quite challenging, and they're a multimodal section of roadway, and we're looking at sort of blanketing a critical section of the roadway with LIDAR coverage in order to collect all this data about how all these road users are interacting with each other and get a complete picture of the roadway, not just at particular kind of points along it. So with that, I'll turn it over to Austin, and he's going to go through all the exciting developments in Chattanooga.
Thank you, Rob. So I'm going to go through a case study that I did here recently in Chattanooga. It's a great example because it comes full circle and has a direct impact here on the road users here in Chattanooga, as well as our ongoing deployment of LIDAR here in Chattanooga and some applications that sit on top of it. So, the University of Tennessee, UTC, where again I work, the safety department came to us a while back with this map that you can see here. And these were zone safety zones that were very concerned about due to historical incidents, observations for pedestrian safety, specifically also student safety. There's a lot of activity in these zones in combining those incidents, and they wanted to look at the cameras that are currently deployed throughout across campus. And unfortunately, as we kind of started to explore that, the coverage wasn't there for the cameras. There was a lot of obstructions, and we looked at potentially procuring cameras and kind of building out the infrastructure just to monitor these zones. But in parallel to that, we had that ITSTN project that required us to build a mobile truck trailer. Data collection trailer, as we call it, very similar to what Will had shown earlier. These have hydraulic solar. This is completely solar and battery operated. It contains a camera, LIDAR, and thermal. And for the use case that I'm going to discuss, we only use LIDAR. So what we did is we went back to that map that the safety department here at UTC had developed, and deployed the LIDAR at one of the highest risk locations that they had identified. We did a data collection over a 4-day period to kind of analyze and understand, pedestrian movement through that big block, and with the goal of kind of analyzing the risks of pedestrians and also seeing what we've done to intervene and improve the safety. So. So the initial deployment, again, went over 4 days. On the left-hand side of your screen, you'll see the trajectory heat map of pedestrians. Again, there's no dedicated mid-block crossing there, so there's a lot of activity across the entire mid-block. On the kind of the southern side of the map that you see, there's a lot of the dorms on that side, and a lot of the classrooms, some of the northern parts. There is some reasoning on why there's so many crossings here, as well as the distance between the two existing intersections. So over that 4-day period, we had 518 unauthorized crossings, 207 near misses with 5-second post-approachment time, and 33 near misses with a 2-second post-approachment time. And on the right side of that, you can also see that trailer deployment at that location during the data collection. So, working with UTC, we took this data to the city of Chattanooga, is very close collaborator and a partner on all our research. And the conclusion was to put a temporary mid-block crossing in and do another kind of 4-day data collection to see, how that changed the pedestrian behavior. And we received some very exciting results. I think we're all happy to see it. So again, you see that same heat map for the post-temporary mid-block crossing installation. We still have some, rebellious individuals, a handful of them, but we had 487 utilizing the crosswalk, 33 outside the crosswalk over that 4-day period, but we reduced that down to 0 near misses, which is more than we expected. Again, this is only over a 4-day period, so But these are still great results to see. I think we were all happy to see the results. I believe the city of Chattanooga has now made that a permanent crosswalk. And I really like to see these projects because they come full circle, right? They actually affect people and road users here at Chattanooga. So the next step, I'm going to talk about the LIDAR deployment here in Chattanooga. For time's sake, I'm not going to go into each of the specific expansions, but back in this started out in 2018, deployed what we call the MLK Smart Corridor. We deployed a wide range of technologies, more than we needed, to be honest, looking back, and we refined that. But that original corridor, the dark blue locations, right along Martin Luther King, MLK Boulevard, very close to where we are today. And that's now expanding out to roughly 130 intersections. We're right in the middle of the city working hard on the procurement processes. This is funded through NSF, USDOT, FSWA, as well as a handful of other funding agencies. But these locations will all include, two LIDAR execute process. In the city, last we spoke, is planning to utilize this also for actuation, so there's additional benefit there. We also have small highway deployment. We have 5 locations mainly monitoring the on and off ramps, the main arteries of downtown Chattanooga. For those locations, we use long range directional LIDAR. They cover up to 750 meters of detection range. And that's again to help understand and continue improving traffic flow here in Chattanooga, Tennessee. As part of that deployment, we also have roadside units, additional edge compute. There's a much larger technology stack, but LIDAR is the core of that. And a couple of applications that we're working on today is really integrating through cooperative awareness, utilizing LIDAR to enable cooperative awareness to improve, road user safety. And that project is ongoing with a smart phase 1 grant here in Chattanooga, Tennessee. We're also going to be looking at interoperability through CDX, utilizing data coming out of LIDAR as well. And with that, I believe that's all I have. Thank you. And I'll pass it back to Moderator.
So I know we're running a little behind the schedule here, so I apologize for that. But we're about the last presentation slide on modernizing your roads and the case study of Franklin, Tennessee's smart traffic upgrades, presented by Whitney Nottage from Q3, Moser from the city of Franklin, Tennessee, and Moderator from Cisco. Moser is the Franklin, Tennessee city traffic engineer and has worked in many states, including Michigan, California, and throughout the Southeast for his 25-year career in both public and private sectors. He's been involved in many ITSTN traffic engineering projects, including planning, designing, operating, and maintaining many different technologies. Whitney Nottage is the Executive Vice President of Traffic Management for Q3, responsible for business operations of Q3, Knellinger. Whitney has spent over 17 years in roadway operations and design across over 100 agencies in the nation. She is a PDOT who supported ideas similar to traffic engineering projects, including design, operations, deployments, and maintenance. Moderator is Cisco's lead transportation solutions architect for America's smart cities and transportation. Mark has been a Cisco architect for 17 years and has transformed Cisco's connected roadways business to include advances in edge compute, data architecture and integration, and authentication and security. He attained and has held Cisco's highest engineering certification, the CCIE, and holds a patent on edge IoT security. Please welcome.
Alright, thanks everybody. I know we stand with you guys at lunch and probably getting home, so we'll try and move through this quickly. We're going to talk about Franklin, Tennessee's technology upgrades they've been doing across the city. Adam will talk about that. They've been upgrading the entire city from the edge through the network in their TMC and done a lot of technology upgrades across every piece of infrastructure. And then Mark and I will cover some considerations if you were looking to upgrade your own technology in your own agency, including interoperability, communications, cybersecurity, and then we have a couple of questions for all three of us as a panel. So we'll start with Adam.
Thanks, Whitney. That's not Frank.
Signal Tech, we got a CMAT grant in 2018. And we finally, like Whitney said, kind of end-to-ended it. We got the software in our traffic operations center, which we're in the jail right now. We moved to the police department in the jail, so if anyone wants to come visit us, you're welcome to come to jail. But we got the grant, and the biggest challenge is really technology moves quicker than the CMAT grant. So it's very difficult with federal grants, and I think everyone up here knows that when you start out with one technology, you might change to something else. And so we did select Q-free max time control level. That hasn't changed much, but the central software went through a process. We started out with max view, and we originally went after the CMAT grant, chose that, and went to kinetic signals, now we're with kinetic mobility. So during that process, we worked with our IT department and got the latest and greatest central software there. Along with the kinetic mobility deployment, we also put in some automated traffic signal performance measures, 2 different systems. Luckily, kinetic mobility comes canned with some ATSTN software and some reports. Those are right on the right side and get there. And then we also tried out mileage and tripod. It's a tripod was bought by Vision. It's a pretty neat software. We're still learning. Lessons learned there, very detection intensive. Anything ATSTN is very detection intensive. Moving on to connected vehicle technology. We do have some various things. We have ComSignia RSUs. We have an application for that. We're going to sit out there. And then applied information on the State Route 96 corridor. That basically goes from Arnold Road all the way to downtown Franklin. If you download the Travel Safety app, you can actually get spat data and see it. So that's through cellular. That's not the LU RSU thing. So they're using cellular. And so it's just a little demo. On the right side is one of our Explorers. And it's running spat data right there. You can see the signal change on the display, ready for green, and the signal changes. So, there's also red light warning with that, headlight warning, you have the app. And so we got a bunch of RSUs out there, but we're really not using the RSU with you. We don't have any applications yet, but they are. Lastly, on our tech, we put in DIRT, I think Control Technologies kind of showed one of our intersections. It's on 10 HDIE CCTV cameras overlay, using that. And then we're also trying some detection, some LIDAR and smart micro, trying to figure out how to replace our existing detection for Scoot with a kind of all-in-one unit, so that we don't have an advanced detector and a stop bar detector, different technologies, trying to make one technology. So another piece of our tech, and it actually came in this past year while we're doing everything else, is our marine preemption system. It is all software based. There's no hardware, kind of like the National's trying out. It's a county-wide project, so it's Brentwood, Franklin, and Williamson County EMS. So what it does is the trucks, we'll call them apparatus, let's call them apparatus, I call fire trucks. The units basically give their position, send a signal request message through the cloud. Preemption request goes to our ATCMTD controllers, and preemption is given, granted. You can play with the ETA, like this by time of day eventually, because the corridors are different congestion, so the ETAs are always different. Could be congested, longer ETA, so hopefully that'll be in the future. So I'm doing Clay's piece. He's our fire captain, couldn't be here today. But they've seen response times go down. So we have 2 different vehicles, Engine 2, and what they call Fast 3, which is the SUV. And you see the response times from October to January, and they go down quite a bit there. I guess the preemption system is doing pretty good. That's their average response time.
Thanks, Hasan. One of the unique things about that preemption system, I think, is that the drivers are being fed a live route, and the route is feeding the preemption calls to the controllers in real time end to end. So if the driver has to reroute for some reason due to a roadblock, the neutron software is going to adjust that and change the signals that it's in those preemptions to, which is pretty neat. We want to talk about some of the upgrade considerations that should be made when you're going through a massive upgrade like Adam has in the city of Franklin. And then the first is a focus on interoperability, demand interoperability. If you don't know how, it's on the left side of that slide, which is where your operators have to go to one system for their video, another system for their signals, potentially more than one. In the case of, say, West Virginia, they have 2 signal systems because they have 2 controller manufacturers, and they are not interoperable. So that can be really inefficient for your operators when they are responding to safety critical incidents if they have to go window by window from an application to application. So debating that interoperability is really, really important. We like to show what we consider important spec language and make sure you did this, get this interoperability. Adam did this in his specifications. You should have functional specifications, not prescriptive. Don't write specs that are around that speak to your existing workflow and say, if I press this button, I want this result. Say, I want your software to give me this result. So focus on the functional, not the prescriptions. Require open sharing. And it's not enough to say, I want an ATCMTD compliant controller, or I want an ATCMTD compliant sign. And that is because most of the specs only cover some of the functionality of those edge devices. So even in a sign, which is a very, very simple device, the 1203 protocol does not cover all the functionality of that sign. So unless that sign manufacturer is giving you 100% of their protocols, you won't be able to integrate 100% of their functionality into any system that you go to purchase. Require the integrations, require your vendors to work together and ensure that you're getting people who are going to be collaborative and work together throughout the life of your contract. And make sure that you have contract mechanisms for future. Adam mentioned CMAC moves a lot slower than technology, and if you're not considering the ever-changing environment of technology as you go to work on your procurement and contract mechanisms, you can find yourself behind before you even start. Mark's going to come up and talk about some other considerations around spectrum, communications challenges.
Last mouth for you today. So last year at ITSTN, I actually showed an example of how the FCC ruling really changed from DSRC to CBDX, and we lost a very big portion of the spectrum. And so when we look at Franklin and other areas, we're really looking at how can we bring applications to bear over a lot more technology than just CBDX. Justin, for your deployment, you guys have done that transition, and you're seeing that. But the spectrum that got taken away is really affecting the amount of applications we can deploy in that new spectrum. So we moved from 75 megahertz to 20. And so Laura Chase was here for the opening, the keynote, and she actually brought up all the working groups we have at ITS America. One of those working groups is called Beyond 5.9. And it's what can you do outside of CBDX? Because if we only have 20 megahertz and we're trying to cram everything into it, that's going to be a problem as we go and expand and go drive to scale. So we defined in ITS America 89 different applications. We pulled all the DOTs on those. This is a short list of those. But I really want to point out to the right side of this when you look at things like the latency requirements of an application. And ITS America utilized Georgia Tech to run a study on what those latencies would look like for applications, and those were included in here, and then that was part of our committee response. So it came out in the 5.9 deployment plan, or beyond 5.9. So if you look at that, we've got latency estimates there, and it's really saying that there are some applications that will absolutely require CBDX. So when we look at a place like Franklin, they're deploying multiple access technologies where multiple applications can be deployed. We'll show you a couple of these. But I want to leave this on the screen for a second, because if you think about an intersection collision, and you've got 2 speeding vehicles going to a collision, 20 milliseconds is the response time you have with them communication there. You're going to be forced to see CBDX, right? But if we talk about a work zone warning, or emergency vehicle preemption, or other applications that have a longer latency, and they're latency tolerant, we can use additional technologies. So as you build out a system, it's important to recognize the fact that we no longer can say that everything that you want to do at scale can go into one technology. And so multi-access is really the thing of the future, and that Beyond 5.9 spectrum report out of ITS America really represents that. So I just wanted to call that out, and then I want to show an example of that, and really when you look at Franklin, what we're doing there, EVP started over there, private APN, right? So there's a private APN they have where all the vehicles are connected to that, it's fleet controlled, and then you can use cloud between municipalities for that same application function throughout municipalities. But if you look for something like SPAC, you want to have an infrastructure that can deploy that across multiple spectrums. So a traditional SPAC is in this mode where you're sending that communication through the RSU, right? It's received on the vehicle. But what most people don't understand is there are low latency methods that we can use to send that even through the cellular network to a public LTE interface. Verizon and AT&T both have capabilities through their MEC, their mobile edge computer on their cellular networks, to do very low latency. And we proved that. We've got some really good white papers out on that. But that can get it to every LTE type device. So now we start thinking about some of these applications where we can move higher delay tolerant applications into the cellular network and reach everything, every car that has an LTE interface and every cell phone. And so if we keep expanding that and we look at other applications, there it is, okay. So we can actually start bringing that, like the example of Franklin, you can bring this through an APN. It could be a FirstNet APN. You can use a customer APN through a private, like Verizon, so it may not be prioritized, but it may also be a capability to have within the fleet. That would be EVP through that. You can use EVP through the MEC and do that low latency type communication. And then you can also facilitate EVP, as in like Georgia, through the CBX RSU. And so when you start really considering an infrastructure, there's no one answer anymore, right? We really have to look at how do we enable multiple transport methods to be used for applications. And so that was really what we're showing in Franklin, is the ability in the cabinet to be able to connect through all these different technologies and move applications across each transport as it makes sense for those applications. And so we just wanted to share that because it's a growth of where we were last year. We were stuck with this massive amount of spectrum, and now what we're showing is proven results on how we can utilize multiple transports for those applications.
All right, so we're going to finish up with just a couple of questions that we posed for everyone to discuss real briefly. This first one's going to be for Adam. What are the lessons learned of upgrading so many different pieces of technology at one time?
So we're smaller, considered as a city. I guess, challenge is learning so much with a limited staff. It'd be great if we had a champion. We don't really have a champion, so we all kind of learn little bits and tidbits, and so you put all the software in, and we have to learn it all at once. It's a little challenging. So we have a lot of stuff going on, and it's challenging to get full use of it. So we're not there yet. I think it's going to take a while to get there.
Marcus, this is for you. What is the biggest challenge the traffic industry faces today as it relates to cybersecurity?
Yeah, I think we've talked security quite a bit today, and it's really great. But when we look at things like NCCIP protocols, and we're seeing there's not really been a big advancement at the protocol layer for cybersecurity, and so we have to take considerations on the network side. But I think it's important in the standard bodies to really start pushing for cybersecurity to be part of those standards, and for legacy protocols to be removed from devices and to start making them mandatory. I think that's a big push.
This is what did play, they didn't make it. What considerations would be made when selecting, deploying, and implementing a single hardware creation?
Well, there's a lot of lessons learned that we're learning. It's a new system. I think some of the things that you look at is, am I compatible with existing AEL technology on the apparatus? That's number one. We did have to put a new GPS antenna on the apparatus and actually create a little bracket for the cradle point, which is a cellular modem, to get that separated from the typical AEL, as well as figure out how to put the screen up for the driver. The engineer, not in our sense, but the fire engineer would sit in the passenger seat and tell the driver where to turn. That was the past. And now the driver has a screen, it shows him the route, and he gets the pre-engine, so that's kind of cool there. So that leaves the engineer prepared for what their approach, instead of telling the driver where to go.
One of the interesting things about this, the engineer and kind of the feedback we got on the system is you look at an EVP system for EVP, but what you don't really realize is there's a lot of additional things that you can give to fire that benefits them. And what we've heard from them is like there's hydrant locations in the EVP route, so they know where to go. There's other dispatch units and their ETAs that are included in that display. And so operationally, it's really helped fire by not recognizing it's just EVP for the sake of getting through a signal, but adding value to what the firefighters need. And that's one feedback that I think they had for us that was really interesting. So don't think of an application as just an application, but a way to help people that are utilizing it.
I'm not to take lots of words about the generational change that's happening in ATMS systems today. ATMS systems used to be monolithic, thick client-based systems, and we're starting to see a shift towards microservices. This is new for the traffic industry. It's not new for the tech industry. The tech industry has been doing microservices-based Linux, Kubernetes architectures for years. And it's not uncommon for the traffic industry to start doing the technology industry has been doing 15 years later, and that's where we are today. The biggest challenge that we're seeing as we work with agencies to deploy these types of architectures is that most ITs are Windows shops. They're not used to Linux. They're not used to a distributed system like these modern ones are. And so it's a really big change for the IT divisions that we're working with most of these times in the States to make the adjustment to more modern architecture that we're going to start seeing long term. Thank you for your time. Hopefully we got things to go.
Thank you, Whitney. So, open the floor for a few quick questions. Sure. Try to shout your questions. Anyone has any questions? Hello, can I hear you? So I have a question for Justin. So as we are talking about the BTS data, so I'm more interested to know about the data size, the frequency, and how you are storing them, and also what is the retention policy? Just if you can give some idea about that.
Yeah, I wasn't being modest, I had no idea. That pan select system we're using right now, Cirrus is the name of the platform, is how we're storing that data now. We're not storing back our network at all. We work with a couple agencies who are a little bit more in the data themselves, so be happy to talk more about it. And still getting our arms around it, honestly. Sorry.
Thank you. And I got another question for Andrew. So as you discussed, like a lot of collaboration between like all the three regions, you put together for region on, and also you engage some other like DOT, like North Carolina DOT, and some mapping tools like drivers and all those systems. So my question is that like, what are the challenges that you encounter when collaborating with multiple teams within that short period of time?
It's communication. So making sure that all of the, as we were trying to get cell coverage back on board, as we were talking back with other DOTs, it's making sure we set up different times for check-ins. So like we had a noon check-in, we had a 4 o'clock check-in, and we had an evening check-in as well. And making sure that everybody's just communicating across those different regions and with other DOTs.
Okay, and just one thing with that, like some of the DOT like ATDOT, so they probably may encounter this sort of ideas and other steps very frequently. So did you take any help or suggestions from them? How do they, or what sort of measures or actions do they take during
this. And the big thing that they assisted us with was bridge inspection. So they went out and they used their, I think it was an IRIS, ArcGIS-based mapping tool, and they went out and helped us and then showed us how to use it. Because, you know, within a week or two after they came to help us, they had to go back and get ready for a hurricane that was impacting them. So they showed our guys how to use that tool and then send them out. And then they went back. We actually sent a strike force team to help in Florida. So
here complain. So what is the adapt signal system? So do you have any cost benefit analysis like after implementing it versus before implementing it in terms of maybe delay and safety?
Yeah, we did it as part of that grant. We did a before after analysis. It's a 5-to-1, so cost. So we have a 5-time benefit to both. It's mostly travel time. We did look at side street delay. Obviously, adaptive systems they all operate a little bit differently. There's only so much time to give, and we actually kind of restrict it a little bit because we don't want it to go to 255 seconds, which you could do for a cycle line. So we tried to restrict it down to like 160. So what that did was it has to manage time within it. But the nice thing about the adaptive systems is it'll change cycles. So where we weren't doing that with time-based cycles. And that was your biggest cost benefit is going up and down your cycle line as traffic came in it. Which is why we put it on our mall. So the mall, you never know what's going to happen. That's why.
We're going to close the Q&A. I would like to thank all speakers, presenters, and audience for your patience, and would like to welcome all the chapter presidents for their final closing remarks. Mackey, Hasan, and Hackett.
I'll do a few announcements quick while I take the final picture. Start with the most important stuff. If anyone lost a pair of black gloves on the shuttle last night to the Reed Hotel, see me after. A couple quick announcements for ITS Tennessee. Want to invite everyone to our annual meeting, which will be April 29th through May 1st out in Knoxville. More information to come on that. And then just a few notes from Michael Rebick. Our annual awards are open now, along with nominations for board of directors. Please reach out to any of the projects. We have email on that as well. Annual student scholarship application is open as well. And finally, I'll talk over last really. One thing everyone about that, we had a great time. Appreciate all of being here. And really thankful to ITS Georgia for the partnership opportunity. Great to see what's happening in both states.
And I do want to add on to that, again, thank you to all volunteers from ITS Georgia, ITS Tennessee for making this all possible, the technical committee for managing each of the events, the sponsorship committee for bringing us all together, the AV team who has made this all possible and working through all the high noises. Huge shout out to you guys, thank you for that. The housekeeping items on the ITS Georgia front, of course, as a reminder, ITS World Congress is our annual event this year. So please join us in Atlanta from October 24th and 28th for that. We're all looking forward to seeing everybody in this room attending. If you have not paid your membership dues, which is at least one of you here, those are up right now. And then you'll start getting some nasty grants sometime in March, I think, if you haven't paid those. Our next monthly meeting will be the fourth Wednesday in February. That'll continue all the way through the rest of the calendar year. So go ahead, put those on your calendar. You can check out the calendar on ITS Georgia's website as well. If you want to go ahead and block those times in your calendar. If you're interested in volunteering for any of our activities throughout the year, we'll either through my Arcadis email address, which is Matthew.Glasser@arcadis.com, or president@itsgeorgia.org. With that, everyone, please drive safe. Take your time getting back home. This isn't a race. I'm going to see you at the next annual and monthly events.
Thank you, sir.
He's so